Okay, very good morning to all. So I think last lecture we have discussed about the formulas related to major energy losses and minor energy losses. So we know that there are two formulas are there to calculate the major losses. One is related to Darcy-Weisbach equation, or we can call it as a Darcy equation, and another is Chase's formula. And then after we have solved the numericals on the Darcy-Weisbach formula and Chase's formula, and then we, one by one we have discussed about the different formulae required for the minor losses. So now today we'll take revision. I told you that everybody should get prepared about the minor losses formulae, and we'll now go to the revision of formulas of minor losses. So first formula, first minor loss, we'll tell. I want that you should remember. Or first is their major loss. We'll here discuss it short. Already we have solved the numerical also, but still as it is very important. Major losses. Major loss is due to what? Is due to MCQ will ask. MCQ they will ask due to major loss happens due to anybody.
Friction.
Friction. Good. Very good. Major loss happens due to only due to friction. So due to only one reason is there for major losses, and that is friction. Due to friction. And there are two formulas to calculate the major loss. So now I request everybody to be, I will ask anybody, okay, roll number 6. So due to friction, what is first formula? Roll number 6. Who is roll number 6? Okay, we'll tell first formula. What is the name of that formula? It is called as Darcy formula or Darcy-Weisbach equation. They have derived the equation, therefore name is given as Darcy-Weisbach equation. Darcy-Weisbach. What is formula for Darcy-Weisbach? Anybody?
HF is equal to 4
Correct. HF is equal to
4FL V square.
4FL V square divided by 2G.
2G.
Okay. So with the help of this formula, one can calculate the major loss due to friction. It's very popular formula. Okay. And where F is coefficient of friction, L is equal to length of pipe, V is velocity, G is acceleration due to gravity, and D is diameter of pipe. And second formula is what? Chase's formula. Anybody? Chase's formula. Chase's formula is here. Chase's formula. Now who will tell Chase's formula? Anybody? Chase's formula.
V is equal to C into root mi.
Correct. V is velocity of where V is velocity is equal to C where change is constant into square root of m into I, where C is change is constant, m is equal to, what is m is equal to? Hydraulic mean depth or hydraulic mean radiation. What is formula for that? It is area divided by perimeter of pipe, weighted area divided by perimeter of pipe, and is equal to, generally it is equal to d by 4. Okay. And I is equal to, what is I? It is frictional resistance HF divided by L. So means if you put the value of I here, it is HF divided by L, and we can get this changes formula. Then HF also we can calculate. But importantly or maximum time we are going to use this Darcy-Weisbach formula, or it is popular one. It is accurate one. Okay. Then we have seen major losses formulae. We have seen the numerical also on the major losses, and then we have started to have the formulae for minor losses. Okay. So minor losses. Now, who will tell first minor loss? Those are not speaking. I request them to speak. Okay. So Balaji, I think you want to answer. Correct, na? Balaji, you have given answer, na? So first
Yes, sir.
formula. So Balaji and Nikita, they have answered. Others, please reply now. When nobody is replying, then I, Balaji and Nikita will reply. But others, please reply. Somebody other than Balaji and Nikita.
Loss due to enlargement
Gaurav,
of
good.
pipe.
Okay. Loss due to head loss due to loss of energy or loss of head due to
Enlargement of
okay.
pipe.
Loss of head due to sudden enlargement of pipe. Loss of head due to sudden enlargement. Okay. What is that formula? H enlargement. Now who will tell H enlargement formula?
H is equal to V1 minus V2
Okay.
bracket square upon 2G.
V1 minus V2 bracket square divided by
2G.
2G. Correct. Minor losses happen due to velocity change only. Okay. Divided by 2G. Okay. Then second formula where I know that here V is the velocity in smaller pipe. These are the enlargement losses. Okay. And velocity is what in smaller pipe? This is pipe number one, pipe number two. Okay. Velocity in pipe number two is what? V2. Velocity in pipe is what? V1. V1 is velocity in smaller pipe and V2 is velocity in larger pipe. Second formula. What is second formula? Anybody? Loss of head. Loss of head. Loss of head due to contraction of pipe. Due to contraction of pipe. We'll tell this formula. Loss of head due to contraction. Now Gaurav also will not tell because here Balaji, Gaurav and Nikita. Other than them. Very important chapter for MCQs. Very important chapter to solve numerical. So loss of head due to sudden contraction. Who will tell now formula?
HC is
Gaurav.
equal to
Okay, Shivani. Okay, good. HC is equal to H contraction or HC is
V2
equal to
square upon 2G.
V2
V2 square upon 2G.
V2 square upon 2G. Whether it is correct or K into what is formula? Anybody V2
V2
square
square
upon K into will write K into V2 square upon 2G. Am I right now? And K value is nothing but what? It depends on the coefficient of contraction. Where K is equal to I think 1 upon Cc minus 1. Am I right now? Shivani?
1 upon 0.62. Right, sir. म्हणजे
1
CC ची व्हॅल्यू 0.62.
1 minus Cc here bracket square. Am I right? And when Cc will take, when Cc will take Cc as a 0.62. That also we should remember. Na? When Cc is equal to 0.62, K will be काय Shivani 0.3
0.375.
when Cc is equal to 0.65 and if Cc value is not given, Cc not given, then K should be Cc is not given
0.5.
0.5. That everything we should tell. Cc is not given, then K is equal to what we can say 0.5 we have to take. Generally Cc value is not given, then in that case we have to take K is equal to 0.5 and in that case Hc will equal to what? In this case, second case, I will write this as Cc. If Cc is not given, then every time they will not give Cc. So generally we have to take it as a HC is equal to, or H contraction. You write the full name, or HC is equal to 0.5 V2 square divided by 2G. But what is V2? V2 is what? Velocity in which pipe now? Contraction means again smaller pipe or larger pipe?
Smaller pipe.
Smaller pipe. V2 is velocity in smaller pipe. Very good. Now next loss. Now I think Shivani has also told. So those have not replied. Please, like, okay, I'm happy with your all spirit. Okay, next loss. We will tell next loss fast, because if you know the formula, then and then you can solve the numerical and we can understand something. Next, we'll tell. If nobody is ready, then Shiva, others, those have replied, Shivani, Gaurav, Balaji, Nikita, they can tell. Fast. We don't want to waste
Head
time.
at entrance.
Next, Nikita. Head loss due
Loss
to?
of head at entrance.
Head loss due to entrance, correct. Okay. Head loss, not due to head loss at entrance. Head loss at
Head
entrance.
loss at entrance.
At entrance, okay. At entrance. And what is formula? Is simple formula.
0.5 V square upon 2G.
Okay. 0.5 V square upon 2G. What is V? Velocity in pipe. Okay. So if reservoir is there and here there is a pipe, then this V is what? V represent the velocity in pipe. Okay. And fourth loss, we'll tell.
Loss
Head
of
loss
head at exit.
exit. Okay. Head loss at exit. And this is equal to what? Here I will write H entrance. H enlargement EH entrance. Okay. So what is formula for head loss at exit? H exit we can say
V square upon 2G.
V square upon 2G. Good. Where V is also velocity in pipe. Okay. Then this is what we have fourth loss. Fifth loss in that case is what? Anybody? Other than this, Nikita, these people, anybody is interested to give the answer? The head loss due to? You can tell now, anybody. Those are anybody now. Head loss due
Due
to?
to sudden obstruction.
Okay, head loss due to sudden obstruction. Due to sudden obstruction. What is that? Here H obstruction we can write is equal to, we will tell, V square upon, anybody? V square upon, what is formula for that?
V square upon 2G in bracket.
V square upon 2G in bracket 1 upon capital A. Anybody?
Capital
Capital
A
A
upon
upon
CC.
Capital A upon CC in bracket A minus small a. Am I right now?
yes, sir.
Minus 1. Its bracket square. Am I right? Right now?
Yes, sir. Yes, sir.
Okay. This is what? Where V square velocity in pipe, A is area of pipe. So if this is a big pipe is there, and if this is smaller obstruction is there, like this, then this is if area, cross section area of pipe this much. This is the cross section area of pipe, and if this is the area of obstruction, maximum area of obstruction, then V is velocity of fluid in pipe, liquid or fluid. G is acceleration due to gravity, and Cc is coefficient of contraction as usual. Its value may be 0.6. And okay, these is square. Then here sixth loss will be very simple. Head loss due to pipe fittings. Am I right? head loss due to bend. Okay, or first we have taken bend and pipe. So here head loss due to bend is equal to what? H bend is equal to, anybody?
KV square upon 2G.
Kv square upon 2G, where K is coefficient of bend, okay, and V is velocity in pipe. And seventh loss, final loss is there, that head loss due to pipe fittings, like bend. Here another pipe fittings are there, head loss due to pipe fittings. What is that formula? H pipe fittings is equal to formula again, K into V square upon 2G, where these are the bends. These are the formulas that day we have seen. Everybody understand all this revision? No problem. Shall we proceed? That yes, in message box. Okay. So Shivani Nani giving a, okay, yes. Only one reply got. Others please reply. Okay. Okay, then we'll proceed. Huh? Now there are simple numericals are there. We will not here because numericals, we are going to take numericals on simple numericals may be asked in the examination. Okay, like this. So we is find the head loss. First example, we can write find the head loss when a pipe of diameter 200 mm is suddenly enlarged to a diameter of 400 mm. The rate of flow of water through the pipe is 250 liter per second. Okay, so pipe is of diameter. This is one pipe is there of here of having diameter. So we can say D1 is equal to here 200 mm is 0.2 meter. And suddenly enlarge to the diameter of D2 is given as 0.4 meter. So 400 mm is 0.4 meter. Okay, and the rate of flow Q is flowing through this pipe. Q is equal to, so this Q they were given. So this rate of flow is Q is equal to, this Q is equal to 0.25 meter cube per second. And they asked to calculate the head loss due to entrance, due to sudden enlargement. What is formula for that? Is equal to H is equal to V1 minus V2 bracket square, okay, divided by 2G. Now we don't know V1 and V2, but we know the continuity equation. What is continuity equation? Q is V1. We know that Q is equal to A1 V1, area of pipe at section 1 in pipe 1 is also equal to area of pipe into velocity in second pipe. And from this we can get that V1 is equal to, we got here Q upon A1 and V2 is equal to Q upon A2. And then we can get V1, we can get V2, and loss of head due to sudden enlargement will be coming as 1.816. Everybody understood? Write down this numerical and I will give practice numerical for you. If understood, please write yes. Very simple numerical. This kind of numerical may ask for our examination. Only we have to use the formula and we have to calculate the head losses. Understood and over. That way you can, our practice is there. Understood and over. Please go. Please follow the practice. Please write my message box. Understood and over. And otherwise, if any doubt is there, yes. Oh, good. Okay. Understood. Okay. Then one practice numerical I will give to you, because we will not, because many numericals they are asking on group losses, where all losses we have to contribute. Okay, then write down. Instead of this, you can go for that pipe diameter is, you can take it as a 300 mm. Okay, write down. Find the head loss due to sudden enlargement. Find head loss due to sudden enlargement when pipe diameter of 300 mm suddenly enlarged to 600 mm. With this practice, I think here you solve this numerical and tell me the answers. Head loss due to sudden enlargement when pipe of diameter 300 mm is suddenly enlarged to a diameter of 600 mm. Diameter of 600 mm. The rate of flow through the pipe is 250 liter per second. 250 liter per second. Okay, what the numerical is given. So diameter is changed here. Head loss due to enlargement. D1 is equal to now here. I've given 300 means I will write directly 0.3 meter. Point 3 meter, and D2 is equal to suddenly enlarged to 0.6 meter, and Q is equal to point Q is equal to point Q is equal to 0.25 meter cube per sec. H enlargement is given by, or H enlargement is equal to, very simple, sudden contraction. H enlargement is given by V1 minus V2 bracket square divided by 2G. Okay, so V1 is equal to Q upon A1 is equal to 0.25 divided by pi by 4 into D1 means 0.3 square. And is coming as anybody, and V2 is V1 is coming as loss. Shivani, you got answer for what? This is a final
Sir,
answer.
याची final
Okay,
answer.
final answer. Okay. Everybody getting final answer. Okay. Rakesh, Nikita, 0.35. Okay, 0.35. Good. So V1 is coming as something, and V2 will calculate, and finally Q upon A2. Somebody can tell for others, those are solving, those are not using calculator. Any V value of V1 and V2. Shivani or Nikita Pawar or Rakesh Birazar, somebody can. V1 value, V2 value.
V1 is 3.54
V1 is 3.54.
and V2 is 0.884.
0.88 will write, okay, meter per second. Okay, and then final answer will be what? H enlargement is equal to 3.55. Okay, good. Dikshad Mill also solving good. 3.55. Okay, so I think we'll proceed to next numerical. Okay, now next numerical is there. Write down the rate of flow of water. Rate of flow of water through a horizontal pipe. You write down those. So you write down the rate of flow of water through a horizontal pipe. The rate of flow of water through a horizontal pipe is 0.25 meter cube per second. Is 0.25 meter cube per second. The diameter of pipe, which is 200 mm, is suddenly enlarged to 400 mm. Suddenly enlarged to 400 mm. So you write down numerical and then. Okay. Everybody has written numerical. Soham, I think Soham. Unmute Soham. Okay. Am I audible? Have you written numerical? Now what they are given that this numerical is same. Previous numerical. Okay. So what is there? They asked the rate of flow. The rate of flow of water through a horizontal pipe is 0.25 meter cube per second. The diameter of pipe, which is 200 mm, is suddenly enlarged to 400 mm. The pressure intensity in smaller pipe is 11.772 Newton per centimeter square. Determine loss of heat due to sudden enlargement. Second, pressure intensity in larger pipe. And third, power loss due to enlargement. And these, I think, first parameter already we have calculated. Am I right? So power in the first numerical, the rate of flow of water through horizontal pipe is 0.25 meter cube per second. Second, the diameter of pipe, which is 200 mm, is suddenly enlarged to 400 mm. The pressure intensity in smaller pipe is 11.772 Newton per meter square. Determine loss of heat due to sudden enlargement, pressure intensity. So whenever they will give the losses, okay, information about loss, then we have to use Bernoulli's theorem for real fluids. And now first is there is important sentence that whenever write down this also, whenever information of loss of loss is available, then here Bernoulli's theorem should be used by considering losses. Write down because I am writing because it is very important. Henceforth, we have to use this by considering losses. When losses information or losses calculation, we can do losses calculation, then we can have to use Bernoulli's theorem with losses. Okay. Now here, first is enlargement loss calculation. So H is equal to H enlargement is given by V1 minus V2 bracket square divided by V. Okay. Now this calculation we have done. So H and learn. So this calculation I think everybody is knowing. So 1.816. This is loss internal error. 1. 1.816 meter. Okay. Second is there, we have to use Bernoulli's theorem by using losses. So there are two pipes we know. One is N smaller pipe is enlarged, and this second pipe is there. So this will be pipe section second means section pipe 2 will consider, and section 1 means pipe 1 will consider. Then, but we have to use Bernoulli's theorem about losses. Which losses information is available to us? Means P1 upon rho g, pressure intensity in smaller pipe, okay, plus V1 square upon 2g plus Z1 should be equal to anybody. Pressure, anybody? Or I have tried. Somebody is interested to tell? Am I audible or I was audible? Somebody?
P2 upon rho g
Okay. P2 upon rho g
plus
plus, correct,
V2 square upon 2g
V2 square upon 2g
plus Z2 square.
Z2 square. Why Z2 square? Z2 only, na?
हाँ Z2. Sorry.
Okay. Plus, if loss is available, loss information is available, whenever information of loss is available, then Bernoulli's theorem should be used by considering losses, and is equal to what? Plus which information head loss is available, that H enlargement losses. You would understand this up to this? Please tell yes and write down this. Understood? And over, yes, over that our practice. If doubt is there, ask doubt. Yes, over, you can write our practice. Yes, and over. Okay, Nikita Power, yes, over. Okay, Pramod Avlikar, yes, over. Only two replies. Shwani Nane, okay, Gaurav. Okay. Then we'll directly go to their solution. Okay. So here answer we got first answer. Then let pressure intensity now in the larger pipe is P2. Okay. Then applying Bernoulli theorem before sudden enlargement by considering enlargement loss where they have written. Okay. But pipe is horizontal. As pipe is horizontal, then we can calculate not Z1 is equal to Z2 because pipe is horizontal. Pipe is horizontal, we can write here. And in our simple line, pipe is horizontal. Pipe is horizontal. Z1 is equal to Z2. It will get cancelled. Okay. And then they have cancelled Z1 is equal to Z2. Pipe is horizontal. Then P1 upon rho g plus V1 square upon 2g is equal to P2 upon rho g plus P2 square upon 2g plus He. They have cancelled Z1 and Z2. Or we want P2 upon rho g, therefore P2 upon rho g is equal to P1 upon rho g plus V1 square upon 2g here minus V2 square upon 2g minus He. This formula is there. Then they have put all the values and they have calculated that P2 upon rho g is coming as, finally P2 upon rho g is coming as, but water is flowing. First of all, P2 upon rho g P2 upon rho g is coming as here 13.21. 13.21 meter of water. Write down meter of water. Then as we want P2, Therefore, 13.22 it should be multiplied by rho of water, the 1000, and G is 9.81. Therefore, P2 is coming as what? 1312.96 Newton per centimeter square. And when we want to calculate power loss due to sudden enlargement or any loss, then we have to use the formula P is equal to, here, don't use divided by 1000. We'll calculate in watt first. Rho Q G into H enlargement. Okay, and here after getting answer we'll get in watt, then you convert into kilowatt. So answer in kilowatt will be what? Here it will be 4453 watt, and kilowatt will be 4.453 kilowatt. You will understand, write down complete numerical and then write down message yes or. I will give 2 minutes to you. 2 minutes to you to write the complete numerical. Such can, because we are having MCQ type of examination, therefore simple examination they may ask. They will give velocity V1 and V2 and they will ask to calculate. Sometimes they may give V1, V2 and they will ask to calculate energy loss due to sudden enlargement. Don't waste time. If it is over, then write quickly message yes over. Okay, yes over. Good. Keshwani Nani, Balaji PC. Both only 2 are over. Please write all of this. Nikita Pori yes over. Okay. Okay, then next numerical we will go for contract losses. Same numerical is there, only we have to calculate the head loss due to contract and find head loss. Okay, find. So sorry, it is okay. So we'll go proceed. A horizontal pipe. Write down this numerical. A horizontal pipe diameter 500 mm. A horizontal pipe of diameter 500 mm is suddenly contracted to a diameter of 200 mm, 250 mm, is suddenly contracted to a diameter of 250 mm. Full stop. The pressure intensities in larger and smaller pipe is given as 13.734 Newton per centimeter square and 11.772 Newton per centimeter square respectively. Find head loss due to sudden contraction if Cc is 0.62. Also determine rate of flow. The pipe is suddenly contracted here. Let this, we can go for pictorial presentation. Okay. And here diameter they have given. This is a diameter D1 is here 500 mm, means 0.5 meter. So from that area A1 we have calculated. 0.1963. Similarly, D2 is knowing 0.25 mm and A2 is 0.04908 meter square. Okay. So pressure intensity in larger pipe is given as 13.734 Newton per meter square, and it will become 13.734 into 10 raised to 4 Newton per meter square. Similarly, P2 is 11.772 into 10 raised to 4 Newton per meter square. Now, head load due to sudden contraction, that we formula we know. Okay, V2 squared divided by 2G in bracket 1 upon Cc minus 1 bracket square. Or if we know directly that if Cc is 0.62, this formula 0.375 V2 square divided by 2G, where V2 square divided by 2G, V2 means velocity in smaller pipe. Now from continued equation we have A1 V1 is equal to A2 V2. Therefore V1 is equal to A1 A2 V2. Okay, now here discharge is not given. Okay, but in venturimeter derivation or orifice derivation, we have replaced this V1 in terms of V2. Okay, so that in Bernoulli equation we have to use this, we have to use to get the relationship between V1 and V2. Okay, so V1 is equal to A1 V1 is equal to A2 V2. Therefore, V1 is equal to A2 V2 divided by A1. So it will become pi by 4 d square. It will get cancelled. Therefore, d2 square d2 divided by d1 bracket square into V2, not square. It is not square. It is not square. It is wrong. It is 0.25 divided by 0.2050 V2. So V2 we got relation that V1 is equal to here 0.25 V2 or here V2 by 4. Okay. Now to calculate discharge, either we should know V1 or A1. Q is equal to A1 V1. So if we know V1 or V2, we can calculate. We can calculate discharge. Q is equal to A1 V1. Okay. Or V1 if we know, then we can calculate discharge. But now we are not knowing discharge. Therefore, what we do? Applying Bernoulli's theorem before and after contraction. Means applying Bernoulli's theorem. Both pipes are there, two sections. But as information of loss is there, we should consider head loss due to sudden contraction. So P1 upon rho g plus Z1, okay, is equal to P2 upon rho g plus P2 upon rho g plus V2 square upon 2g plus Z2 plus H contraction. But Z1 is equal to Z2 because why? Pipe is horizontal. They have given reason that pipe is horizontal. Therefore, P1 upon rho g plus V1 square upon 2g is equal to P2 upon rho g plus V2 square upon 2g plus head loss due to sudden contraction. Now, head loss due to sudden contraction is given by 0.375 V2 square divided by 2g and V1 is equal to V2 by 4. Means what? All this equation we want to convert into V2. This equation will become what in terms of what? V2, and we can get the value of V2. Now we can put the value. P1 is given. Okay, P1 is 13.3734 into 10 raised to 4 divided by 9.81 into 1000 plus the value of V1 we can take it as a 0.5 V2. So V2 divided by 4 bracket square divided by 2g. Okay, and is equal to P2 value P2 upon rho g plus V2 square upon 2g plus 0.375 V2 square upon 2g. Now this all things, now this equation is in terms of only in terms of only in V2 or only in terms of only in terms of V2, and then we'll get value of V2. Okay, value of V2 is coming as what? Here after solving this, V2 is equal to 5.467 meter per second. After getting this value of V2, suddenly we can calculate head loss due to contraction. That is not that much use. So loss of it due to contraction 0.375 V2 square divided by 2G is equal to 0.375 into 5.467 square divided by 2G. It is value is coming as 0.571. Rate of discharge either Q is equal to A1 V1 or Q is equal to A2 V2. So area we are knowing, V2 we are knowing, it is coming as what? 2.263 0.2683 meter cube per second. But our practice is there that we should express it in terms of liter per second. Therefore, 268.3 liter per second. And this much only they have asked. Everybody understood or any doubt? Understood? First tell me understood or not. Yes. Then you will write. Yes. Okay. Pramod Avlekar. Yes. Nikita Boy. Yes. Okay. Good. Then write down. I will give you 4 minutes time. Okay. 4 minutes time you complete it and tell me over. Please mention that over. Chat box. Please write your message. Chat box over. over शिवानी आणि निकिता पवार, बालाजी पिसे, गौरव, शुभम शिंगण, somebody. Okay, good. We'll proceed to next numerical. The next numerical is there that in if in the problem 11.11 means this problem only whatever we have solved, the rate of flow of water is given 300 liter per second. If this is the rate of flow, other data remaining same, find the value of coefficient of contraction. So other data means here P1 is going to be same, okay, then D1, D2 they are going to be same, and we have to calculate, find the value of coefficient of contraction. Shall we be able to solve, or I have to help? I have to solve. Somebody can reply me in chat box. Able to solve independently. Only contraction coefficient of contraction we have to find out. All remaining data is same. Here CC is not given. Reverse we have to go for. Okay, we will try. Okay. Now here in previous this numerical here what they are given, now Q is given. So Q is given as what? Q is given as 300 liter per second. So Q is equal to 300 liter means I will write here 0.3 meter cube per second. And in this case what will be there now? From this we can calculate immediately V1. There is no relation, is not required. Q is equal to Q upon A1, and here is equal to 0.3 divided by A1 means 5 by 4, or already calculated here, we will use that value. That value of V1 will use. Here A1 means 0.196 will use. Zero point 196, and it will come as, anybody tell me the value? V2 is coming as like this, Q upon A2, and is coming as 0.3 divided by A2 means already calculated 0.049. Or 9, and is coming as, somebody can tell, please tell. Then we got V1 and we got V2. Then using, anybody, still that I will write, using Bernoulli's theorem, by considering by considering head load due to contraction. Okay. Somebody have to tell value V1 and V2 or in message box. Then Bernoulli theorem will be what? P1 upon rho g plus V1 square upon 2g plus 2g plus z1 is equal to the pipe is horizontal, therefore z1 is equal to z2. HC will now we are knowing P1 upon rho g. V1 already you might have calculated. Okay, P2 upon rho g and V2 square upon 2g. Then we'll get HC value, meter of water. Okay, and then HC is equal to what? We are not knowing CC value, therefore they will ask HC is equal to here V2 square, that we already were knowing value, V2 square divided by 2g in bracket 1 upon CC minus 1. HC is knowing, V2 square knowing, and CC is. Now I want answer from you. This is the structure of the numerical. Everybody, nobody is solving. Tivani Nane, Nikita Pawar, Shubham, value of V1 and V2. Nobody told me. Okay. Nikita Pawar, V1 is equal to 1.53, V2 is equal to 6.12. 6.12 meter per second, and V1 is coming as okay. And then HC is coming as anybody? HC value tell me, somebody I can tell HC value. Tell, or somebody can tell, or write in message box HC value. Or calculating. Please calculate fast. Somebody can tell. Fast. If our method is correct, then I think we should not be confident enough. That is not the case. We'll check answer from book and book value also. This is solved numerical from book I have taken, because so that we can confirm our answers.
Hello, sir.
Ah,
Sir, CC we can also calculate by A1 by A2.
how we can calculate A1 by 2?
Sir, we know A1 and A2 also.
Then how? What is formula for calculating CC?
So coefficient of contraction is equal to A1 by A2.
But that is rough value. That is in terms of orifice. That is not that much effective one. But it is. This is in this way we have to calculate. This is related to orifice. That
Yes.
formula what you are using now, that is for orifice meter. It is orifice contract here in this case. Orifice is there. So here we have to use this formula. It is not the orifice, na.
Yes,
The
sir.
pipe
Yes.
is only contract. So that formula you are using now, that is of orifice meter. So here we have to use this formula. This way we have to calculate. Okay. Nikita power got answer H is equal to 0.21. I'll write only two digits of 0.21. And sudden HC is then HC value we have to put in this equation. V2 we got, and we will get CC value. Somebody can tell me CC value also. Too much time you are taking. 0.1. Calculated. Too much time you are taking. Nikita Power, I think your can answer may be correct. Are you ready? Little bit wrong now, I think. HC everybody got 0.21. Point 20, correct. And H is equal to 0.75. Sorry. Near about 0.75. Are you getting answers like this? Are we getting answers like this? 0.6 is equal to 0.75. Shivani, Nani, Nikita Power, please. Others. Okay, so I think only few of them, Nikita Power and Shivani, Nani, they got 0.21. Okay, others. Then CC value is 0.75. Okay, is everybody understood and over? Please write. Understood and over. So that we'll proceed to next. Point 56. It is wrong. I think V2 squared divided by 1 upon 60. It is 0.75. It is coming. Look, answer is 0.75. You check answer. Somebody can check. So answer is like this. Book answer is point. Shall we proceed? Next numerical 0.75. Everybody got 0.749 means point. I am considering as a 0.75 near about. Getting or anybody? Shivani, Nani, you check your answer. 0.748. Pramod Avlegar. Good. 0.7483. Good. Pramod only got correct answer. First answer. First person to get correct answer for CC. Point 75. Okay, Shwan. Good. So we'll proceed with this. I think everybody understood. We'll go to losses numerical. We have to complete today only. Otherwise, it's taking a lot of time. Shall we proceed? Yes or over? Yes over. Head down. Please reply yes over so that we proceed to next. Doubts are there? Please ask if anybody has doubt. Okay, Pramod Avlegar yes over. Already he is correct. Others please reply. Saurabh yes over. Okay. Then now we'll directly take the numerical from book now. We'll look at this contraction. Then this kind of so here other numerical you can take from book. The problems are there you ask me. So loss of heat at entrance is given by formula 0.5 v square divided by 2g. Okay. Exit v square divided by 2g. Bend obstruction pipe. Here it is going to be v square upon 2g in bracket a upon cc in bracket a minus small a minus 1 bracket square. Okay. Then bend k v square divided by 2g. Similarly, there are simple formula they can ask here. Water is flowing through a horizontal pipe of diameter 200 mm. Water is flowing through a horizontal pipe of 200 mm at a velocity of 3 meter per second. A circular solid plate of diameter 150 mm is placed in pipe to obstruct the flow. Find the head loss due to obstruction if Cc is equal to 0.62. What they have given? This is one pipe. Okay. Having diameter D means capital D is the diameter of that pipe. So D is given as 0.20 meter d. Then this is one pipe is there, solid plate is there, and this plate is having small d, this is capital D, and this diameter of the plate is given as what? 0.1550 mm, it's 0.15 meter. Okay, and area we can calculate from this area of cross section of pipe, we can calculate A, and maximum area of obstruction we can calculate small a. So A and small a d, okay, from this. And velocity, I think they have given 3 meter per second. So whatever the fluid is flowing, water, so it is flowing with velocity of 3 meter per second. Okay, then our formula, we know the formula is v square upon 2g. V is 3 meter. A we know. C they have given a minus a, and then we can calculate the equation. So I will give this, solve it, and tell me where next page we are getting the answer. Understood? Right hand over and then solve it and tell me the answer. Edge obstruction. This formula would use edge obstruction is equal to square divided by 2g in bracket a divided by cc into small capital A minus small a minus 1 brackets. Everything we are knowing. V 3 meter per second, a capital A, small a, and only we have to do the calculation. Somebody can tell edge obstruction. Calculate. Don't make laziness in the calculation for doing the calculation. Don't be lazy. Do the calculations. Please tell me answer so that we will proceed to 2 points I want to cover today. I think we are taking too much time on this chapter because this is very important. Okay, good. I am getting answers. Okay. So Nikita power 3.38, 3.26, 3.31. So 3.3 is common. I will write 3.3. 3 meter. Now I will check. Correct. 3.311 meter. Correct. Very good. Okay. Now all the numeric other losses are there. So one complete numerical will take next class, and we'll introduce with this other numerical losses. Okay. Now before that, there is one concept of hydraulic gradient line and total gradient line. Now we know that the fluid is having when the fluid is flowing through the pipe is having three types of energies. One is pressure energy or pressure head, that we can call it as P upon rho g. Okay. Then another head is what? Here kinetic head, V square upon 2g. Okay. And on left next head is what? Potential head. Okay. Now if the concept of hydraulic gradient line and total energy line, I don't hydraulic gradient line and hydraulic gradient and total energy line. In short, it is called as HGL, hydraulic gradient line. It is called as HGL, HGL, hydraulic gradient line, and another is what? Total energy line, TEL. One is what? Hydraulic gradient line, and another is what? Total energy line. Hydraulic gradient line, HGL, and another is what? Total energy line. Okay. So write down. The concept of hydraulic gradient line and total energy line is useful in study of flow of fluids through pipes. They are defined as, I done first, hydraulic gradient line in bracket HGL. It is defined as the line which gives the sum of pressure head and datum head of a flowing fluid in a pipe with respect to some reference line, or it is a line which which is obtained by joining top of all vertical ordinate showing the pressure head and the datum head. Write down. Sir, in my language we will take definition. Write down. Hydraulic gradient line is the line. Hydraulic gradient line is the line which gives the sum of pressure head and datum head or potential head of a fluid, of a flowing fluid, of a flowing fluid, of a flowing fluid in a pipe with respect to any reference, with reference to any reference. So the line which gives the sum of pressure head, that is what? P upon rho g. So write down HGL is what? In mathematical, or in short we can say HGL is nothing but what? P upon rho g plus datum head. It is called as Z. Okay. So what are the points are there now? In this reservoir is there, one reservoir here they have shown. Okay, and they have shown this is a, so at every point. So this I want this B point. What is the value of HL? Means at B point, what is the pressure? Okay, plus what is the velocity? What is the potential? It may be the 3 meters. So this will be the point G. Afterwards, the point if we consider this point B dash point. So B dash point, what is velocity? What is pressure? And what is datum? Okay, so that is nothing but what? With reference, suppose that this is the one reference is there, and from this reference at point B means it is a Z we can take, and pressure plus here also pressure plus this value of Z. So this is called as datum. Okay, so this value means what? What is pressure Datum is what is pressure plus what is value of datum. Datum is height with reference to this height. Okay. Or if you are considering this as a datum 0 plus this height and their pressure. Okay. So then point number C, B dash, you can say B dash ह्या पॉइंटला काय असेल हे datum आणि ह्याचं प्रेशर, या दोघांचे ऍडिशन. इथं दिस इज व्हॉट TL. आता हे कसं झालंय तर इथं लॉस कडे आपण we are getting, so here more energy, input energy is there reservoir, and we are getting energy goes on decreasing because fluid is flowing in this direction. Okay, so TL is also decreasing and HGL is also decreasing. So ह्या पॉइंट वरचं किती हायड्रोलिक ग्रेडियंट एनर्जी आहे तर ही आपण ग्राफच्या साहाय्याने जर आपण पॉइंट आउट केली तर काय, इट इज अ लाईन, अगेन अनदर डेफिनेशन इज दॅट इट इज अ लाईन which is obtained by ह्या सगळ्या पॉइंटची, ह्या पॉइंटला किती एचजीएल आहे, ह्या सगळ्या पॉइंटला आपण प्लॉट केले, त्या सगळ्या ऑर्डिनेटची जर आपण एक ऑर्डिनेट बनवून एक जाणारी लाईन पास केली तर ती काय असेल एचजीएल. पण ती ऑर्डिनेट म्हणजे काय तर पी अपॉन रो जी व्हॅल्यू ऑफ प्रेशर हेड अँड पोटेन्शियल हेड. ओके, सो इट इज अ लाईन which is obtained by joining top of all vertical coordinates showing the pressure head at a flowing fluid in a pipe and potential head. Okay, then like this another line is there, it is called as total energy line. It is called what? Total energy line. So it is defined as the line which gives the sum of pressure head. The total energy line is what? It is giving the pressure head at that is okay. It will give the line of pressure head plus kinetic head plus potential head. Means what? Here, what is which term is there? It is defined as the line which gives sum of pressure head, datum head, and kinetic head of a flowing fluid in a pipe with respect to reference line. Or it is also line defined as the line which obtained by joining the top of all vertical lines showing the sum of pressure head, kinetic head, and datum head. But reference we are taking as a datum line, therefore difference they are taking as a 0. Okay, means HGL and TL, what is difference? So difference in them is always V square upon 2G. दोघांमध्ये काय डिफरन्स असतोय, TL always having more value, HGL is having less value, and difference in them is always difference in HGL and TL is what? V square upon 2G. So always there is difference of V square upon 2G. Okay, म्हणजे TL always above than HGL by the amount V square upon 2G. Okay, and there are no numerical, only these two definitions are there, and what is meant by HGL and what is meant by TL we should know. So always during the flow, as the energy of the flow is decreasing, TL also goes on decreasing towards outlet. असा outlet decrease होत जाते, HGL पण काय होत जाते decrease, आणि त्याच्या दोघांतला डिफरन्स काय असतो V square upon 2G. जर पाईप जर अशी आपली जर नॉन युनिफॉर्म डायमीटरची असेल अशी तर ह्या दोघांतला डिफरन्स पण काय होतो V square बदलल्यामुळे here this value is goes on decreasing, therefore here V1 and V2 त्याप्रमाणे या दोन लाईन मधला पण डिफरन्स काय होतो कमी जास्त होतो. इट डिफरन्स इज ओनली V square upon 2G. Understood? And write down the definition. Understood everybody? I am going to give these notes to you, no problem, but still that write down in mathematical form at least. HGL is equal to what? Line which use the summation of pressure head and datum head, and total energy line, the line which use the summation of pressure head, kinetic head, and potential head. The difference in between them is always V square upon 2G. Understood? Or shall I repeat or what? Doubt? Please tell. Nobody is replying. Nobody understood. Understood or not? Please reply yes. Okay, Nikita Power. Okay. Good, others please reply yes. So write down definition also. And now we'll take attendance, and you can leave the class afterwards. Roll number 1.
Present, sir. Yes.
Okay. 2. 2 absent. 3. 4.
Yes, sir.
3 present.